Hello everyone. Today I'm gonna give you some information about my study, which is named Acoustic Improvement Design University Conference Hall. These buildings have been in the department of the Istanbul University. Is located in Sakarya, Turkey. It's the faculty of the aquacultural engineering. Sapanca campus consists of the white landscape area such as the dining hall building, conference hall building, education buildings, hotel buildings as well. As well. Now I will explain the main properties of buildings and then the methodology, design strategy, numeric analysis result, and conclusion as well. I will give you some technical properties of this conference area and room. For example, the square of the building nearly 150 square meter, the maximum of interior buildings 7.1 meter, and this building is the built approximately between 1960 and 1970. But this time it has been determined that conference hall is not possible to respond to today's and modern needs because of use different things. The capacity of building is approximately 110. The volumetric of that building is 810 cubic meters. This figure is about the conference hall building interior photos and plan before the application. Why we will do why we will do this design of conference hall, because of the visual and at rest comfort condition is so important, that buildings it is necessary to improvement its properties. For example, where it should be used especially, for example, design of the acoustic conference area, church, mosque, theater, auditorium, concert hall as well. It's easy to apply and it is shifted according to the design. If we look at the design strategy, auditory comfort condition has a vital importance in daily life. Especially the intelligibility of speech is one of the basic parameters of auditory comfort condition. This result interest in speech intelligibility in conference hall building. Acoustical design is developed in order to obtain speech intelligibility in conference hall. And reverberation time control have to provide speech intelligibility in room. The main design strategy, improvement of sound insulation in exterior wall system is suggested to achieve auditory comfort condition. Artificial lighting system is suggested according to faculty of demands. Reverberation time control is suggested to provide speech intelligibility in conference hall. The first step of the study, acoustic evaluation of existing conference hall, is performed and determined necessity of acoustic improvement. Second step of study, acoustic improvement project is developed to generate good acoustic environment in conference hall. Reverberation time analysis is a so important issue for speech intelligibility. How what it being measured is fulfilled numeric analysis by Sabin methodology use this technique. Technical properties of material which are used that area option from literature like sound observation coefficient. Reverberation time should be taken into account separately for the basic frequency. We will use this formula for reverberation time, it is necessary to use a room absorption, room volume, air absorption, and different sound absorption coefficients as well. We measured reverberation time analysis before acoustic improvements. You will see this table according to before acoustic improvements. For example, here the different place of the that buildings, and our frequency is a change between 125 Hz and the 4000 Hz. You will see here mosaic tiles layer, wood covering, double glazed window, double glazed. You will see the different surface and here, and we look at the reverberation time, and we achieved that that with use our formula. For example, 125 Hz, our reverberation time is 4.13, but 4000 Hz we will see see 3.09. It's a changeable each other or frequency type. Here is you will see the acoustic improvement project. For example, you will see here we added here control room. We changed the volumetric properties of our buildings. For example, which study asked for improvement the acoustic. The new control room added the conference hall the perform needs. Reflective wood panel used in scan area. Acoustic fabric panel behind a 10 centimeter rock wool used on wall around the conference hall. Acoustic perforated gypsum panel were used on ceiling between distance holes 18 millimeter and the holes radius is 6 millimeter. The ground area of building is applied use a raised floor and some part of skin covered with wood, another part of floor covered with epoxy. I will show you here our the buildings section, a section. For example, here you will see the gypsum panel. Here is you will see which the type of material used in conference building surface, wall, and the ceiling part of the buildings. For example, gypsum panel used on the wall. The behind of the gypsum panel there have been the 5 centimeter rock wool. For example, ceiling part use acoustic perform gypsum panel on ceiling, and inside of the ceiling panel use the 10 centimeter rock wool, and you will see here absorbent fabric panels behind 10 centimeter rock wool behind of the absorbent fabric panels, and here you will see the steel profile, and surface of the steel profile use the wood covering with wood, and then use epoxy. Acoustic improvement project is developed in order to control reverberation time in existing conference hall. Conference hall interior surface covering was changed and conference hall absorptive surface was increased to control reverberation time. The audience seats are raised to improve audience visual and sound quality. And here This figure, you will see the conference hall building interior floor surface covering and ceiling surface covering. You will see the plan. We use a different color here. For example, brown color is a reflective wood panel which one use on skin ceiling. Yellow, epoxy surface covering. Magenta color use floor covering in the square area. Dark blue is use acoustic perforate gypsum panel which are used on ceiling. Pink one is use a gypsum panel substanding ceiling. If we look at the legend, it was used different color of material which one used in a conference hall. You will see all of the color here, and I give you the information before to you. And then here is, you will see how we will use our the acoustic panel and wood panel, which is placed in a surface of ceiling, wall, and the floor of the ground of the buildings. You will see here the different section of the our buildings. For example, CC part section surface covering with a wood door, reflective wood panel, and DD section surface covering with absorbent fabric panels. We use the behind of the fabric panel, the 10 centimeter rockwool and open textile fabric, and the brown one we use a surface of the ground of the buildings, reflective wood panel 10 millimeter. You will see all of the material here. Here is, you will see after the acoustic improvement project, you will see the reverberation time analysis according to new acoustic project proposal. And look at here, red one, you will see the reverberation time. It was it was less than before. For example, 125 hertz is 0.78. 4000 hertz, we will see the here at 0.56. And you will see here the conclusion is all the last one. I will give information about our conclusion. If you look at the table, you will see rehabilitation time analysis results show that the figures decrease between the 125 Hz and 4000 Hz due to use observation panel and change the room volume. And for example, blue one is the reverberation time according to acoustic project proposal is less than the before and maximum value to be desired in reverberation time. The green one here is changed between 125 Hz and 400,000 Hz. The time section is the same, all of the frequency hertz. And the right part, you will see here the figure before and after the reverberation, before and after the acoustic panel. You will see how it was a change the reverberation time after the use the acoustic panel. It was really so less, all of the frequency hertz here. For example, if we give furthermore, there are many advantages of this. For example, it's obtain the speech intelligibility, it's achieve the authority comfort condition, it's acquired a much more healthy acoustic environmental. We win this properties of the buildings. Before, there are the many the problem have been there. For example, unfinished background noise, it's not clear to understand speech due to there are no any voice isolation, the voice mix each other. After that we implement these properties. I am really pleasure to give me this opportunity. Thanks everyone.